Okay. You guys definitely do. Whoever this was has at least one outlier, if not more. No. Yeah, that's tough. I think that's a yes. This one is going to be... How is that below 0? Oh, it's not. It's at 0. Okay, that's okay. It's just Excel's calling that. I can see it there a little bit, actually. Sorry. This one is a no, I think. That's definitely a yes. That's a no. That's a no. That's a no.
Yeah.
That one I think is a no, but it's hard to tell. This one definitely is a no. No. And I want to call that one a yes because it's a little too close for me to chop. How did I do?
So we should have a mark or don't?
Which one? Which one? Well, this one I think should not. No, it should have one. I think I'm going to call that one says should. How did I do? Was that too fast?
That's good.
Yeah.
How did I do? It was too fast. It was too fast. Okay. Laura, which group were you guys?
We're the one with 43.5, so 1, 2, 3, 8.
Oh, here you guys are.
Yeah.
You guys, this is going to be a tough one for me. Hang on. You guys don't have one.
No.
Okay, good. Group 3? I'm going to say it is. It looks like it's close. It's not. See, it's getting too close. And what I'm doing here, and here's, how did I do for the rest of you? Was I catching for the most part? I was, wasn't I? There's a quick, and we're going to explore this more on Tuesday, because this is going to seem a little literally hand-wavy. This box that's right here is called the interquartile range. The middle 50%, the distance between them, 33 to 8.5, is called the interquartile range. Now we know that traps the middle 50% of data. Because that's less than the 95 from the bell curve, what statisticians will often do, and your TI is doing it too, is it takes that middle 50%, increases it by 50%. Now that's a different 50%. It increases the number by 50%. So it takes that length, puts an extra 50% on it. Then it stacks that on top and below the quartiles.
Like 1.5 boxes.
Exactly. 1.5 boxes above and below the quartiles. If anything pops outside of that range, that's considered unusual. That's how I can tell right away, this is clear. You guys must have captured 1973, I think, whoever this was, yeah. So, when I do that, 1.5, and I stack it, that guy is definitely on top. This guy right here, there's the interquartile range, there's 50%. That's not now, is it? That's why group 2 didn't have one. Group 3, 50%. Did I say you guys did have one and you didn't? Yeah, so I can see now, if I do it more carefully, I can tell you don't. It's close though. What I was trying to do without using my fingers, I was trying to be impressive. Obviously, I failed a little bit. So, but what's interesting is, that's why this group and this group might have, who is group, this is group K, which is group 9 and 10. Where's group 9 and 10? Do you guys remember which groups you guys were? Did 9 have outliers?
That might be us.
Might be you. That's okay. It was harder to tell. These whiskers look to be the same length, don't they? But it's not just the length of the whisker, it's also how long the box is too. So that's why you can have a very long whisker like this one, and there's no outlier there, because this box is huge. When you stack 50%, you actually gobble up. So in other words, it's not enough just to have high variation at one extreme. You also have to have kind of clustered lack of variation everywhere else. Going back to your point, Rachel, she said, I pretty much had a bell curve. Why is my average 5 inches different than my median? That one outlier you guys had pulled it enough. Good, good, excellent. More on that on Tuesday. Let's go back to this now. All of you did the same experiment, yet you all got different box plots. Hopefully you can see why.
Is it because you had us put our birthdays in?
I had you put your birthdays in, and even though I think we had a birthday match on the first day of class, chances are you don't have the same birth year. And even if we had the same birth year, chances are those two same people weren't running the machines today. In other words, I'm using probability and pretty much assuming that everybody's putting a different number in the machine to press enter on. Why is that important?
Random.
Everybody do this. We'll come back to this. Grab your TIs. Everybody, if you have a TI, grab it. Okay? Do a little randomization exercise right here. Everybody press the math button. Now go over to the prob menu. This is the one you were in before. Press enter. Hopefully it says RAND on the home screen right now. Now press enter again. I got 0.9083. What'd you guys get?
0.311.
0.3, 0.5, 0.2, 0.908. Okay, now do this. Everybody type 1, 2, 3, 4, 5. The kind of combination an idiot would put on his luggage. In that movie, you know it.
Oh.
You know it, think about it.
Baseball.
There we go. Now, hit the store button, which is right above on, makes a little arrow. Now, math, left, enter. So essentially what you're doing is the same thing you did with your birthday, but you're using the Spaceballs number instead. Fair? Press enter, it's going to say 1, 2, 3, 4, 5. Alrighty? Now generate a random number. I guarantee it's 0.947735585 for all of us. That's the problem. How did I do that? Because we all seeded our machines to the same number. See, the problem with a random number generator on a computer is it's like living in sin. You can't. What's the definition of random? Non-deterministic. Thank you, Rachel. You never know. But what's the definition of a computer? Totally deterministic. Something that takes an input and generates a predicted output. So how can it be random? Answer, it can't be random. So you have to make it be close to random as possible by assigning a random value for a start. What's a good pseudo-random value? Your birthday. Could have used your house address too, maybe, but birthdays seem more logical. Fair enough? Okay, back. Good. Thank you. The introduction to random numbers. Matthew 43. All right, back to this now. Bailey noticed something. She asked me these questions about these little gray lines. Gray lines, gray lines, gray lines. She's like, are those the medians? And your response would be? Yes, those are the medians in each of the data set. And then you said, Bailey, do you notice how, even though we've got wildly different extreme values in our box plots, the median's kind of right across the middle? Isn't that kind of cool? So you do get fluctuation in the extremes. Where do you get the most fluctuation? In the years with more snow or the years with less snow? That's where it looks like most of the variation is happening, the years with more snow. You're getting less variation in these years that are expected. Now some of that's due to the fact that you're measuring from 0, which means there is a bottom, but there's no top, theoretically. We could get 500 inches of snow in town. We could. I hope it happens before I die. It'd be freaking awesome. But we just don't have any, but it does fluctuate even not getting to 500. But here's the interesting part. If I change, look at this. Now, this is like, okay, I see the same graph done twice. This is the actual population box plot. That means I took all, whatever it is, 90 years, ran all 90 years worth of snowfalls in, and graphed them all in the box plot. So in other words, 25%, 25%, 25%, 25%, but each of those has like literally 25 data points in it.
Yeah.
This is the average of all of your results.
So it works, basically.
What works?
The random.
Statistics works! Yes! Isn't that cool? You guys all got varying results, right? We lost a little bit of the outlier,
Yeah,
yeah?
but not much.
We lost, say that again, Michelle.
Not much.
Not much.
Just maybe a couple of the most extreme ones.
And do they matter anyway?
No.
Yeah.
Do they matter? No. What are you after when you're looking for a data set?
The
middle, the average, the median, whatever, the typical. We capture typical almost perfectly. Which leaves one question left. People always were complaining about this winter, up till today, probably. Voodoo opens, I think, tomorrow. Yeah, thank God. But up till today, people were like, this is the worst winter ever. Voodoo's not going to open. My God, it used to snow. It used to snow 8 feet. We had to dig out for 3 days. I remember, you go down to McMinimans.
Yeah.
You walk in that door, there's a picture of the nun shoveling 8 feet of snow off the sidewalk. People were saying, freaking, this winter sucks. Used to get 8 feet of snow. And then I presented with this.
No, we didn't.
I say, okay, I might believe you, except the fact that this is 100 years worth of weather data. Right here. Could you please find me,
the 8 feet.
could you please find me your 8 feet? Now, clearly, it happens because the picture of McMinimans is not fake. I don't think. I think the nun really shoveled the big 8 feet of snow. But what was that year? Goofily unusual. If goofily is a word, I'm not sure it is. This is average snow depth from 1928 to 2005, which is roughly the time of period that you guys have on your maps. But this is average snow depth per day of the year. What does the average never get above? 2 inches. Inches. So that 8 feet happened. Guess what else happened?
Nothing.
Lots and lots of days with 0. And all of a sudden the 8 feet gets tamed down and the medians, the truth, if you will, begins to arise. A buddy of mine, Bob Woodward, you guys might know him. Love you, Bob. If you're watching this, love you. He's in the Mountain Biking Hall of Fame, local dude's been building trails here for like 60 years. Still rides harder than I do. The guy's like 85. Posted a bunch of pictures. That's a real winner. He posted a winner 1973. Look at your 1973. Then he posted the next day, 1991. Look at your 1991. Love you, Bob. Watch out for the outliers. He's showing you the best winner. If there was a great winner in Bend, chances are the mountains had a great winner too. You see what I'm getting at? It's so easy to remember those because those are the ones that are memorable. We're not going to remember the January where we were in our t-shirts as much as remember the January we had to snow, we had to ski to get to work. Right? And that's the problem with outliers. More on them on Tuesday, because I want to talk about more quantification of those, but that's enough for today. So you have your quizzes, make sure all your names are on there, and then we'll catch you guys then, huh? Good stuff. Have a good weekend. Play in the snow if you want to. If you can, if you're not. Some people hate snow.